Okay, gentlemen, I just wanted to go over one of the problems on the review sheet and really kind of talk through it. I know for one of the classes, I rushed it a little bit at the end, and we did it a little bit in lab. So in case you were out or missed it, just a quick video on this. So on the classwork we did on Friday or Tuesday, I said provide a function such that the given information is true, and this is what I give you. A couple of things I want you to know right off the bat is when you see this, you know that this means one of the roots is 2/3. F of x is 0. That means this number, comma 0, is an x-intercept or a root. And this tells me that another root is -6, right? These two things, f of this number is 0, means that's a root. F of this number is 0, that means that's a root. This means that I want the y-intercept to be -36. F of 0, f of x, 0, comma -36, that's the y-intercept. So first we start with these. 2/3 is a root, -6 is a root. We always said it's x minus the root and x minus the root, so that becomes a +6. And we're making a function of x, an f of x, such that that's true. So we're working backwards. Now what I recommended is if I see a factor where the denominator, where there's a fraction, I'm going to multiply just that factor individually by the denominator. If there's a factor with a fraction as a root, I'm going to multiply just that factor by the denominator, so I'm getting a 3x minus 2, which is just a whole lot easier to FOIL out. You can leave it, but that's my advice. I would do that. And now this is a whole lot easier to FOIL, or box method, whatever you prefer. 3x squared plus 18x minus 2x minus 12. And then we combine like terms, and we're getting a polynomial, a function, a 16x minus 12. We had said in the first trimester that if you left it with the fraction, you would be getting all these fraction numbers, but that would be a true polynomial that gives you 2 roots, 2/3, and -6. So this one's kind of more common from what we see, but you can leave it in this fraction form, FOIL it out, and you're going to get like x squared, and you'll get something like 16/3 and 4 as your last number. So you'll get a function that gives me those 2 roots, but it looks like a bunch of fractions. So that's why I recommend this. And we had said, really, you could times this trinomial by any number, and it's just a GCF. So you could take out the GCF, and you'll still get the same 2 roots. But now that's where this comes in. I want my y-intercept to be a -36. Right now, my y-intercept is the number -12, because, right, to find the y-intercept, I make all my x's 0. So if I take this polynomial and I imagine making all the x's 0, currently my x-intercept is -12, but I want it to be a -36. How do I do that? Well, I take this whole function and times it by 3. So that will become a -36, and when I do that, I'm getting, zooming out to see the whole thing, 9x squared, and then a 48x, and here's my -36. So now this is a function that meets all those qualifications. The 2 roots, which are the easiest to find, and really I could multiply this by any number or divide it by any number, as long as it's not an x. And I'll keep the same roots. The only thing that'll change is the skinniness or the height of my graph. Once I say I want this to be the y-intercept, I'm narrowing it down. I say I need this number to be a 36, so there's only one answer now. So the one function that meets all 3 of these qualifications is this guy right here. Okay? Hope that was helpful. Good luck on your upcoming test.